I hope you can see the next board up there in the top left. Dichromate, I want to make that from metal. I have 3 rolls. Alright, my 3 rolls are I only buy sand, metal, and what's the other thing I buy? Sand, metal. I'll think of it later, but I only buy a couple things. Otherwise, I get it at the Lowe's or the Walmart or whatever. Anyways, I'm going to show you how to buy some metal, chromium metal online. Nobody bats an eye over chromium metal. And I'll tell you how to take it all the way up to dichromate, chromic acid, chromate, whatever. Anyways, the Riemann-Tiemann reaction, I'm going to do that. Amino acids, I want to make them. I already mentioned the Hell's Woolard Zielinski. That's basically almost 2N-amine, or an amino acid. Malonic ester, I mentioned that too. I'd like to make some R-substituted acetic acids. You need that to do it. Acetoacetate, I want to make that so that I can make R-substituted methyl ketones or R-substituted acetone. I mentioned primary amines. When I say primary amine, I want to make long amines. Fatty, that's a good word. I want to make primary fatty alcohols, primary fatty amines, primary fatty halides. I want big long chains with just one thing on it. Now I want it to be on the terminal, right at the end, not in the middle. Grignards. I want to make some benzene and put some chlorine on there or bromine or whatever, make some bromobenzene and add something onto there with a Grignard, make an alcohol like benzyl alcohol. I think the first Grignard I'll probably do is isopropanol. I know what it smells like. I know the temp. It's a nice whatever. But I am going to do a lot of Grignards. What else? Benzene. You can see that next one. Benzene plus iron sulfate and hydrogen peroxide. You can make phenol that way, supposedly. We'll see. Sandmeyer reaction. That's where you take benzene and you make aniline. Nitrobenzene. You turn that into aniline, and then you turn the aniline into halide. So it's a way to make a halide on there from a nitro group. Anyways, next, Wirtz-Fittig. He actually has two. One is the Wirtz and one is the Wirtz-Fittig. This Wirtz-Fittig is for the benzene ring, if it's aryl. As you can see, you get 2. I have down there, I have bromobenzene and methyl iodide. And you can see what it makes. It makes toluene. And then this next thing here on the pictures, terrible pictures, I see that. But the top ones here, see there? That's a round bottom flask, and you can see on top it's got a condenser. That's how you reflux stuff. I think that's a terrible way to reflux unless you got unlimited money. Because what happens is all the heat, as you can see, you're heating that round bottom part, all the heat just goes right up to where you have your icy cold condenser. And you're just putting ice in there, ice in there, ice in there. It just keeps melting it, man. But look at the next way. Look how I got that little piece in there so it moves it to the side. Now all the heat goes up, but the condenser is moved over to the left or to the right a little bit, so it won't waste your ice. I mean, it's just, that doesn't make any sense the way they reflux. The other thing that doesn't make any sense is the distillation. You can see on these bottom pictures, I show the one distillation is the way that people all do it. It's the way the textbooks tell you. Everything tells you to do it that way. Teachers, colleges, whatever. But what happens is, and I'm going to point to it here, right there where they connect, right where they connect, you get a little puddle. So when you start distilling stuff, you distill stuff over, right? Now you're on your, I mean, it's good if you're just distilling one thing. But if you distill on more than one thing, the next thing that comes over is going to start getting into that puddle. And you've just contaminated your thing. Then when you go to the third thing, now you got the first thing and the second thing in that puddle. And it just keeps continuing. If you do it this way, and I'll show you how it doesn't form a puddle that way. That way you have no puddles whatsoever. None. No contamination. Why would you distill something, spend hours and hours to distill it, if you're just going to have a big puddle there and to contaminate the next batch coming over? Let me switch over my camera here and we'll move over to a different picture. All right, what do we got there? All right, let me see. Oh, okay, that's acetylsalicylic acid here. And what am I going to do? I'm going to take that ester down to an alcohol, so it's salicylic acid, right? Then I'm going to take the salicylic acid, just like when you make benzene. Pretend this ain't here. Right? What's that look like? Benzoic acid. You decarboxylate that, it goes down to benzene, right? And so does it right here. Only difference is I got an OH on there. And I'm going to take that phenol, right? I'm going to take it and I'm going to boil it with some zinc powder. And that's going to take that hydroxyl right off of there. And then I'm going to be left with benzene. Another thing is Colby electrolysis. I want to do some, they make alkanes. One alkane, as you can see, it looks like phthalic acid, but it's not a benzene ring. It's just a cyclohexane ring. Right there. And put some electricity through there, some DC, and it will make the cyclohexene. It'll rip off the, just like down at the bottom here, see here? It'll rip off it'll decarboxylate, and the ends will add together. That's why you get a double bond on that first one here, right? Because this gets taken away, that gets taken away, and then you got a little double bond left there. Other thing I want to do is I'm going to tell everyone how to find on a computer. How do you find azeotrope boiling points? Like I have a program. You just type in the couple components, and it'll tell you if it has an azeotrope, a zeotrope. You know, there's all three of them forming an azeotrope, none of them forming an azeotrope, whatever. Also, how to find chemicals. There are actually programs on the computer where you can go to, and you type in the chemical you want, and it'll spill out 100 chemicals, 100 products that have that chemical in it. You know what I mean? Like, let's say you want toluene. So you type in toluene, and it'll type out 20 products that have it in it. Then it'll tell you the percentage it's in it. It'll tell you all the other chemicals that are in it. It tells you everything. And also how to find boiling points for compounds that you're putting under a vacuum, like you're going to vacuum distill. And I'll give you a secret right now about toluene that I have not heard anyone talk about on the internet. You know, they always say it's impossible to get rid of. You got your ethylbenzene, you got your methylbenzene, and you got your xylenes. They're usually always mixed together, okay? Ethylbenzene is mixed with everything. And let me tell you, they say you can't get rid of it. It's hard to separate them because they're all have the same boiling point. Not the same, but they're close. And here's the secret, okay? The big secret. Methanol forms an azeotrope with toluene. It does not form an azeotrope with xylenes. It does not form an azeotrope with ethylbenzene. Okay? So if you have those in there, all you got to do is throw some methanol in. Now instead of everything boiling at about 120 degrees, right? Methanol, toluene, azeotrope will boil at like 60. It's about 60. I don't know what it is. But that's a lot different than 120. There's 60 degrees off instead of 10 or 20. You know what I mean? That makes it very easy to get it out of there. Then once you got it out of there, it's easy to get methanol out of toluene. I mean, you just throw some water in there and soak it up, and then throw some more salt water in there, soak up the water, and then distill it. You got pure, you know what I mean, pure toluene. Anyways, I think I'm going to have to call this one a day, and I'll be going on forever about what I'm going to do. But I just wanted to see how I post stuff, how I, you know what I mean, let you guys know if anyone's interested. Maybe you've got some questions on what I'm doing. Ask me anything. If you're a student and you're trying to learn something, give me, let me help you. That's all I like to do, is talk about chemistry. Well, apparently you can only have 15 minutes of time on YouTube, so I got screwed up on my videos here. I'm just going to talk for a couple minutes here that I didn't get into. I'd like to also build some stuff like, let me think, what do you call that, a centrifuge, because I need one, and a couple other things like that, you know what I mean, where you have to actually build it to help, like a magnetic stirrer, that kind of thing. Distillation apparatus made out of PVC, you know, that kind of thing. Anyways, two of the things I wanted to emphasize that I, you know, are like my target molecules are indoles and purines. My actual target molecules are lisinopril, and that's a drug that people use for high blood pressure. I actually need that drug. The other drug is acyclovir. I need that drug too. You can't get high off of these drugs, so don't act, you know, don't, if you're one of them people that are just looking to get high or whatever, this is not a channel about that. All right. But lisinopril is some form of purine, I think. I can't remember. And the indoles are it's just another, I don't know what the heck you make out of that, but I do want to get into that. And that's about it. I'm sure I have a million other ideas. I just wanted to see if I can post some videos or whatever. I did want to post probably about 5 videos on physics. Obviously short ones, since you can only have, get out of there, kitty. You can only have, hey, get out of there. You can only have 15 minutes at a time, so I'm going to have to obviously make a few videos or whatever. But they're all going to be basically about time dilation, gravity, and distance, all, you know, how they change from frame reference to frame reference, and how clocks are different from time to time, you know, from one person to another, you know what I mean? And that's pretty much all it's going to be about. Oh, and then the dimensions. I'll go through I think about 10 or 11 dimensions, spatial dimensions, which time is a spatial dimension. And basically that's it. I just wanted to say hi to you guys. If anyone has any questions, I love questions. I love talking about chemistry. You know, if you're a student, even if you're a teacher, you know more than me, you're already a chemist, go ahead, give me, you know, tell me some stuff. Let's talk about it. I like talking about chemistry. That's what this channel is going to be about. It's not about me posting an experiment that has flash or whatever. It's about actual learning. You know what I mean? It's about talking about it and discussing what's better, what's worse, what's whatever. Anyways, guys, that's it. I want to end this video, and you all have a good day.